All right, so this lesson is under a function family reunion. This unit in this beginning lesson is to try to tie in all high school math in terms of what you've learned in different functions and different things, graphs, equations, and so on. So the real focus here is on the function and the graph. So we want to look at the equation and look at the picture of the graph, and can you see all the things that we've done in Math 3 and 2 and 1 and put it together and be able to organize it and think through what it is. So for number 1 here, can you match the name to the equation? So we can start with linear and go look at each one until you find the equation of a line. So that one should be, I think, pretty good. So you know that that's going to match with C. Y equals mx plus b. Then exponential. That means the variable's in the exponent. So as I go through, the only one where I see the variable is in the exponent. That's g. That's an exponential. A quadratic, that means the biggest exponent is 2. So when I look through, I say, okay, I got that. That's e. Polynomial. Now a quadratic and a linear polynomial. What's a general polynomial? So when I look through these, a general polynomial, it's kind of an awkward way to write it, right? This way. But that one there, h, represents a general polynomial where n is an integer and greater than or equal to 0. Rational, that means a fraction, and the variable's in the denominator of a fraction. So that's f. Absolute value, that's going to be simple. Find the bars. So that matches with A. A logarithm, that's going to be simple. Find log or ln. That matches with D. Trig, we just did that one. So B matches with, those are the trig equations. And that leaves a radical, square root, cube root, one of these radical signs. So that matches with 9. So if it be an equation, could you identify it looking at the equation and know what the family name is? All right, turn the page. We're going to do similar work on the next page, but this time it's not the equation, but the picture of the graph. So can you match the picture to the name? So a line, linear, obviously, which one here would match it? So that is F. Exponential, which one looks like an exponential curve? Might be a little bit trickier to remember. So the exponential curve goes up forever to the right, flattens out to the left. D is an exponential curve. Quadratic, what does that picture look like? A parabola, that's C. A polynomial, that one is curved and has turning points. That's going to be B as a polynomial. It goes on forever, it's curved with turning points. A rational, well, that one has a break in it in the picture of a rational. Absolute value, what does the picture look like? Kind of looks like the letter V. Logarithmic, what does a log graph look like? So what does it match with? And notice you have A and you have H. They look similar, but the difference is H goes down forever and up to the right. H is the logarithm. A is actually a radical. That's what a square root looks like. And then which one is a trig graph? So you can see the wave down here, right? So it's going to take a little study and practice, but can you put these functions together, know the picture and know the equation, and you can name the family? Turn the page. In this table of values, can you complete it? So I'm given a function. What name would you give that function? A quadratic. And then you have transformed it. So you've been adding 2. So if you add 2, what does that mean? That means the y coordinate you add 2 because it's on the outside. And then you could see how do the original points, the parent points, change when you add 2 to the y value. And that's what happens. Now look at this column. You're not told what happened. So in this column, you have to look at the parent and the third column and see, are there any changes? So -2, -1, 0, 1, 2. X stayed exactly the same. So for this one, we're going to map it and say X stayed the same. How about for the Y? 4 became 8, 1 became 2, 0, 0, 1, 2, and 4, 8. So what operation did we use to go from 4 to 8? Did we multiply times 2 or add 4? Well, whatever you do, you have to do the same for each one. So if you think it's adding 4, when you go 1 plus 4, does it match? How about if you multiply 4 times 2? Would it match? Remember, 0 times 2 is 0. And you can see that we're taking the y coordinate and multiplying everything times 2. So we're going to call this f2 at x. And then x squared, if it's the y, it's on the outside. So this one will be in the front on the outside. And that's 2x squared. That means that if I plug in negative 2, the answer is 8. Negative 1 gives me the answer 2. 0 gives me the answer 0. And you can see it matches. All right, let's try the last column. Look at the x's. Do the x's match? No. So what might have happened? So negative 2 to negative 3. Negative 1 to negative 2. 0 to negative 1. 1 to 0. 2 to 1. So when I look at the y values, how did they change? And for each one, you subtracted 1 for the x value. So when I map this out, the x's now, you have subtracted 1. How about for the y? Did the y change at all? Nope, the y's all stayed the same. Now for this one, we're going to call it F3. What you just did goes inside. And when it goes inside, you have to undo it. So instead of subtracting 1, it's going to be adding 1. So because to every x coordinate you subtracted 1, when you write the equation, we have to undo the subtracting 1 for x. Do the inverse, which is adding 1. So if I put negative 3 in, negative 3 plus 1, that gives me negative 2 squared 4. It matches. So we have a function that matches the table of values. So y does what it says, and the x does the inverse. All right, let's try another one. Okay, what would you name this parent? 2 to the x. That's called an exponential. So when I look here, you're given the parent, just x, y, and then you're given more table of values. And can you see the transformation that took place? So first look at the x's. Did the x's change at all? No. So we're going to map it out and say, nope, the x stayed the same. How about the y's? Well, the y's changed, and how did they change? I'm not going to start with the fractions. I'll start with 4. 4 became 16, 2 to 8, and so on. You multiply times 4, and 1/2 times 4 is 2. 1/4 times 4 is 1. It matches. Now, when it's the y value, it does what it says. So what it says for us to do is take 2 to the x and multiply it times 4. And we took the multiplying in front of that function. Next, third column. Did the x's stay the same? Yes. How about the y's? Nope. And then look at, go bottom top. So don't start with or here. Go bottom top. And how did they change here? So the y values just all became negative. So instead of y, it's now negative y. So how does that change the function? So this should be f1. This is going to be f2. So how does this change? So the y value does what it says. So instead of 2 to the x, it's going to be negative 2 to the x. So we need that negative in front so that it matches. All right, last column. Look at the x's and y's. Do the x's match? No. So tell me what happened to the x's. So to each x, if you look carefully, you subtract 1 to get the new answer. To the y's, they stayed the same. So the y value stayed the same. How does that change the functions? We'll call it 3. And what happens is, in the exponent, that's inside the function, we're going to do the inverse, to undo subtracting 1. So if I want to undo subtracting 1, I have to add 1. And by adding 1, this now matches the table of values, that function. All right, turn the page. Here we have absolute value. That's the name of it. And you have the parent for that. These points match that function. Now look at the points and think, what happened? So x, y, what happened to the x or y or both? So the x's stayed the same. The y's, how did it change? So if you look carefully, you multiplied by -2. Make sure that when you multiply by -2, all of them match. And then how does that change the function? So the -2 is on the outside multiplying, and it does what it says. Look at the next one. And this would be 1. And this one's going to be 2. So how did x, y change here? Did the x's stay the same? No. How did they change? Well, instead of negative, well, what do we do? -2 to 2, -1 to 3, 0 to 4. So it looks to me like the x's you added 4. How about the y's? Any change there? Nope. So the y's stayed the same. So how does that change the parent? Well, because it's x that changed, it's inside the bars, and we have to undo it, the inverse. So it's going to be subtracting 4. That means when you plug in x, it should give you that answer. And it does. Look at the last column. How did x, y change this time? Did the x's change? Look carefully. Yes. How do they change? Subtract 3. Each x, subtract 3. Look at the y's. Did they change? Nope. They stayed the same. So what would that look like if you subtracted 3? So again, that's going to be inside the function, so inside the bars, and you do the inverse. You undo it. So you're going to add 3 for the function. And now they match. So we know that y does what it says, and the x's do the inverse when we look at the table of values and the function. Next table, trigonometry, love it, sine. So it started with xy. What happened to the x's? Did they stay the same? Yes. What happened to the y's? For each y you added 2. So the x stayed the same, but the y we added 2. So now the function, I asked myself, it's the y, so it's outside. And because I'm adding, I'll do it at the end of the function and add 2 at the end. Everything's been shifted up 2. Look at the next one, xy. Did the x's stay the same? No. What happened to the x's? Look carefully. So I might want to start here. So 2 pi and pi. Looks like I divided by 2. It's half, 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 half. And 0 and a half is still 0. So it looks like for the x, it's half. For the y's, they stayed the same. So how does that change the equation? So if all the x values are half, that's inside the parentheses. And how do I undo 1/2? As I multiply times 2. This function matches those points. One more time. And again, you could press pause at any time if it's going too fast, and you try to fill it in and then press play. All right, they stay the same all the way down. So the x's stayed the same. The y's, oh, they changed. And then how did the y's change? If you look carefully, you multiplied by -2. So every y was multiplied by -2 to change them. So now what does the function look like? So if you multiply by -2, that's going to be outside in front. So -2 times sine 2x. And you have your answer. Next, what's this function? That's called a square root function. And those are the parent points. So I want to look and see how has the table of values changed from the parent. Did the x's stay the same? What happened to the y's if you look carefully? And so to each y, what has happened is that you've divided by 2, or half of them. Now how does that change the equation? Well, that 1/2 then goes in front, and it does what it says, so that this now matches that table of values. And this is a 1. XY, look at the next one. So if I look carefully from the parent, the first column, the x's have changed. How have the x's changed? So each x is exactly half the size. The y's have all stayed the same, so the y coordinate stayed the same. So I want to write a function that matches these table of values. So it's the x, so it's inside. And when it's inside, we undo it. The inverse of 1/2. It's multiplying times 2. And 2x now matches this. One more. So look at the last column. Try to press pause now and do it, and then you can press play. What's changed with the x's? If you look carefully, you added 3 to each x. What's changed to the y's? They stayed the same. So how does that change the function? So because it's x, it's inside, and it does the inverse. We're not going to add 3, but subtract 3 to match it. All right, turn the page. The next 2 pages, I don't even know why they're copied. Even the next 3 pages, you can see what a teacher might read through for the lesson. But this right here is the homework part of this packet. So I'm going to stop this video, and then we'll do a new video for the homework book. Mr. G Math, over now.